Here's problem 3110. A conducting rectangular loop of mass m, resistance r, and dimensions a not equal to b is allowed to fall from rest through a uniform magnetic field which is perpendicular to the plane of the loop. The loop accelerates until it reaches a terminal speed before the upper end enters the magnetic field. If a is equal to 2 meters, b is 6 Tesla, r is 40 ohms, and m is 0.6 kilograms, what is the terminal speed? So we have ourselves a loop with 2 meters, and magnetic field is going into the page as it's indicated. That's equal to 6 Tesla. So as this loop starts to enter that magnetic field, the flux will be increasing into the page. This will cause an induced flux to come out of the page, and to create that field requires a current that will be going counterclockwise through this loop according to the right-hand rule. And hence there will be a magnetic force on the bottom end of this wire loop that will oppose the motion as it's falling. The magnitude of that magnetic force is going to equal ILB sine theta, but theta will be 90 degrees, so it's just going to be ILB. The value of the current in turn will be equal to the EMF induced divided by the resistance. That's going to be equal to BLV divided by the resistance. So this magnetic force is going to be equal to the current BLV divided by resistance times L times B, or B squared L squared V divided by R. Alright, that is the magnetic force, but if we reach a terminal speed, then the net force on this object will be equal to 0. That's what we mean by terminal. No acceleration, the speed is not changing at that moment, so we need a constant net force of 0, and hence this magnetic force at that point would be equal to the gravitational force, which is equal to mg. So we have that B squared L squared V over R is equal to mg. We want to solve this for the velocity. So the velocity is going to equal mg times r divided by b squared L squared. That's going to be equal to the mass, which is 0.6 kilograms, times g, 9.8, times r, which is given as 40 ohms, over the magnetic field, which is 6 Tesla, square that. L is the length of the conductor, that's the lead end going into this, and that's going to be equal to the distance A, which is 2 meters squared. This is equal to 1.63 meters per second. So the terminal velocity when these two forces are equal and opposite will be 1.63 meters per second.